In this lesson, we will learn about preparing to configure Active Directory size. First, we will determine how many sites and their associated subnets that we should configure for our AD forest. Then, for the size that we figure out from step 1, how many site links we should create and what are their configurations, and if we should configure silent bridges. And finally, we sum up our lesson with the keynotes. To configure Active Directory size, we must know the physical network where all the domain controllers in the AD forest are installed and connected. The physical network helps determine the number of sites. For example, in our network, we can configure site A, site B, and site C. This size allows us to figure out the subnets associated with each site. For example, site A is associated with subnet 1 and subnet 2. Site B is associated with subnet 3 and subnet 4. And site C is associated with subnet 5. The physical network also helps determine the number of site links where each link is used to connect two sites together. For example, in our network, we can configure the site link 1 to connect site A and site B, and we can configure site link 2 to connect site B and site C. For each site link, we can configure the link schedule and cost depending on the characteristics of the physical network connections. And finally, the physical network helps determine if it makes sense to configure site link bridge to connect two or more site links together. The first question we should ask is how many sites we should create for our AD forest. Per Microsoft, domain controllers that are connected to each other via 10 megabit per second links or higher can be put in the same site, which means we must have the logical network diagram of the physical network to determine how many sites we should create for the AD forest. Here is the logical network diagram of our AD forest. As you can see, we have three locations: Chicago, Elgin, and Aurora, where Elgin is connected to Chicago via the T1 connection, which has 1.5 megabit per second, and Chicago is connected to Aurora via the fiber connection, which has 5 megabit per second. Therefore, we must create three sites in our AD forest: Chicago, Elgin, and Aurora. The sites allow us to figure out the subnets associated with each site. As you can see, Elgin site must be associated with the subnet 10.20.0.0/23, and Aurora is associated with the subnet 10.10.0.0/23, and Chicago is associated with the subnet 10.0.0.0/23. As Chicago is a data center, so it is hosting the VPN clients. So Chicago is also associated with the subnet 10.172.0.0/20. To configure a site, we need to prepare three parameters. The first parameter is the site name. To name a site, we should use a consistent naming scheme such as the city name of the location hosting the site. So in this case, we name by the city, Aurora, Chicago, and Elgin. The second parameter is the server, which lists all the servers in the site. These servers must connect to each other via the connections of 10 megabit per second or higher. As you can see, currently all the servers are in the default first sign name, so we need to move these servers into their site. The last parameter is the subnet, which are the subnets associated to the site. The next question we should ask is how many site links we should create. To answer this question, we need to understand that a site link is used to connect two or more sites together to allow replication to happen between the sites. When there are more than two sites in a site link, these sites must have the same replication costs and schedule. For example, in this default first site link, we included all the sites in the link. So these sites must have the same costs and replication schedule. In a real configuration, a site link should only include two sites that has connectivity to each other and set specific cost and schedule on the link. So in order to configure the site link between Elgin and Chicago, we should only include Chicago and Elgin in the link and set specific cost and replication schedule on this link. When there are two or more physical connections between two sites, it only requires one site link because Active Directory lets network routers to route the replication data via one of these connections. So as you can see, between Elgin and Chicago, we have two physical connections, but we only need to configure one site link because Active Directory will rely on the network routers to replicate the data between Elgin and Chicago. To configure a site link, we need to prepare four parameters. The first parameter is site link name. To name site links, we should use a consistent naming scheme such as name of site 1 dash name of site 2. For example, if we want to configure the site link between Elgin and Chicago, so we should name it as Elgin-Chicago. The second parameter is the size in the site link, which lists two sites connected by the site link. So in this case, the size in this site link is Chicago and Elgin. The third parameter is the schedule, which determines how often the replication happens between the two sites. So in this case, we configure it to replicate every 3 hours. The last parameter is the cost, which gives the priority to one link over another. Cost and schedule must be configured based on the available bandwidth, reliability, latency, and actual costs charged by the ISP. In this case, we configure the cost as the default cost of 100. Next, we should check to see if we should configure silent bridges. As you may know, silent bridges are used to connect sites together so that the relationship can be transitive. To configure a silent bridge, we should prepare two parameters. The first parameter is silent bridge name. To name silent bridges, we should use a consistent naming scheme such as name of site 1 dash name of site 2 dash bridge. The second parameter is site links in the silent bridge, which lists two or more site links connected by the silent bridge. we need to make sure there is physical connectivity between the side links. In a real configuration, a side link bridge should only include two side links that have connectivity to each other to make it easier to troubleshoot replication issues. For example, to connect Elgin site and Aurora sites, we can configure a silent bridge that bridge silent 1 and silent 2 together. So we name it Elgin-Aurora-Bridge, and the silinks in this silent bridge is silent 1, which is Elgin-Chicago, and silent 2, which is Aurora-Chicago. To make the silent bridge function, we need to make sure there is physical connectivity from Elgin side to Aurora side via Chicago side. Let's learn about silent bridge and silent costs. As you may know, if there are multiple silent paths between the same two sites, Active Directory chooses the link with lower cost for replication. When a silent bridge is configured, the cost via the bridge is equal to the sum of individual links. By default, Active Directory enables bridge all side links to connect all side links together, which may cause problem if there is no physical connectivity between the side links. To understand these concepts, let's take a look at this diagram. As you can see, without bridging, the replication between Elgin and Aurora is via the part 1 using the direct network connection configured by Silent 3 with the cost of 250. Let's assume Chicago routers does not route the traffic between Elgin and Aurora. When bridge or silence enable, part 2 is formed via Chicago router by bridging silent 1 and silent 2 with the cost of 200. Now Active Directory will use part 2 because it has lower cost to replicate the data between Elgin and Aurora, and the traffic will be dropped by Chicago router. Therefore, in many cases, the AD team chooses to disable bridge or silence and manually configures silent bridge. Let's learn about service location and silent costs. When a client queries a service that is not available in its site, its DNS server will return a list of servers offering the service. The client uses the silent cost to determine the nearest server. It then queries the server for the service. For example, this client wants to query a global catalog server, so it queries its DNS server in Elgin site. As you can see, Elgin doesn't have any global catalog server, so the DNS server will return the clients with the list of the global catalog server in Chicago, which has the cost of 100, and Aurora, which has the cost of 90. In this case, the client will choose to query the global catalog server in Aurora because it has a lower cost of 90. Now let's get back to our physical network. To configure Silent 1, we can name it Elgin-Chicago because it connects Elgin and Chicago sites together. For the cost, since we have only one connection, so we can keep the default cost of 100. For the schedule, we know the T1 connection is fully occupied during business hours. Therefore, we can configure it to replicate one time between 12 p.m. to 1 p.m. during business hours and every 1 hour after business hours. For Silent 2, we can name it Aurora Chicago because it connects Aurora and Chicago sites, And we can keep the default cost of 100 and replication schedule is every 1 hour. To control the replication path, we will disable bridge or side links. In this case, there is connectivity between Elgin and Aurora via Chicago, so we will configure a silent bridge to bridge silent 1 and silent 2 together, which will allow the replication to happen between Elgin and Aurora domain controllers, and we will name the bridge as Elgin-Aurora-bridge, and we will include in the bridge the silent Elgin-Chicago and Aurora-Chicago. Now we can summary our site configurations into 3 tables. The first table is a site table that includes the site name, subnet, and server. The second table is the site link table, which includes the site link name, cost, and schedule. And the last table is the site bridge table, which includes the site bridge name and site links in the bridge. This is the end of this lesson. Let's read the keynotes